Welcome to day 69. Have you ever wondered how a language model takes a sea of probabilities and turns it into a single coherent sentence? Well, today we're going to pull back the curtain on that exact process.
You know, it's a common misconception that a model just writes, but that's not quite right. At every single step, for every single word, it's staring at thousands of possible options, each with a different probability. So how on earth does it pick just one?
By the end of this, you'll get it. We're going to break down the core strategies that models use to make these choices. You'll understand the simple, fast approach and the more complex, thoughtful one, and you'll know exactly why you'd pick one over the other.
Okay, so this whole decision-making process, it has a name. It's called a decoding strategy. Think of it as the rule book the model follows, to pick word after word, turning a bunch of raw numbers into something we can actually read.
And here is the fundamental problem that these strategies exist to solve. A model doesn't spit out a word. It spits out a probability score for its entire vocabulary. We're talking tens of thousands of options for every single step. The decoding strategy is the critical piece that sifts through all that noise and makes a choice.
So what's the most obvious way to solve this? Well, you could just look at that huge list of probabilities, find the single word with the highest score, pick it, and then just do that over and over again. Simple, right?
This very simple approach is called greedy search, and it's called greedy for a reason. At every step, it makes the choice that looks best right now, without any thought for the future. It just grabs the most likely word and moves on.
But that greediness is also its biggest flaw. It's incredibly short-sighted. It might choose a word that seems great in the moment, but that choice could completely block it from forming a much better sentence just a few words down the line.
This example shows you exactly what I mean. The model starts with the. Greedy search sees that nice has a 30% probability, which is higher than dog at 25%, so it picks nice. But in doing so, it misses out on the much more probable and coherent path of the dog has. It took the immediate win and lost the long game.
So this leads to a pretty natural question, right? Instead of betting everything on a single path, what if we could explore a few of the most promising options at the same time?
And that is precisely what beam search is all about. Instead of following just one path, it keeps track of a handful of the most likely sentence fragments. These are called beams. It's like exploring multiple possible futures at once, hoping to find a better overall result.
And the main knob you can turn here is called the beam width, often written as num beams. This just tells the model how many parallel paths to keep an eye on. If your beam width is 1, you're just doing greedy search. If it's 5, the model is tracking the top 5 possibilities at every step.
So how does it actually work? Well, at each step, it takes its current set of beams, let's say 5 of them, and figures out the next most likely words for each. This creates a whole bunch of new, longer sequences. Then it scores all of them, and, critically, it throws away all but the new top 5. It's this constant cycle of exploring and then pruning back down. So when you put them side by side, the trade-off is really clear. Greedy search is blazing fast and doesn't use much compute, but the output quality can be, let's just say, not great. Beam search is slower and needs more memory, but it usually produces much better, more coherent results because it's thinking ahead.
So where do we actually use these? Well, both greedy and beam search are what we call deterministic. Give them the same input and you'll get the same output every single time. That makes them perfect for tasks where you want the single most probable, most factually correct answer, like in machine translation or text summarization.
Now, it's really important to note that for more creative jobs, like writing a story or building a chatbot, you usually don't want the most predictable answer. That's where a whole different class of methods called sampling strategies come into play, which introduce a bit of randomness. But that's a topic for another day.
To wrap this all up, decoding strategies are the essential bridge that takes a model's raw statistical guesses and translates them into actual readable text.
And the real takeaway here is that there's no single best strategy. It's an engineering choice. You have to ask yourself, for the task at hand, do I need the single most probable answer, or do I need something a little more interesting?